A boat traveling with the current took 3 hours to go 30 miles. The same boat went 12 miles in 3 hours against the current. What is the rate of the boat in still water? Let's let x equal the rate of the boat, how fast the boat is traveling in still water, rate of boat in still water, and we're going to let y equal the rate of the current. And we're going to set up a chart to help us organize a lot of the information that we're given within the problem. We're going to set up a distance equals rate times time chart. So let's construct a chart. And the two rows, let's label those rows traveling against the current and traveling with the current. So we'll let our first row be with the current and our second row be against the current. And we know that rate times time is equal to distance. And we will try to fill in as many squares as we can with the information that we're given within the problem. We're trying to figure out x and y here. X being the rate of the boat in still water, or how fast the boat is traveling without the effect of the current, and then y being the effect of the current. And we know that when we're traveling with the current, the water current is adding to the boat current. So an expression that we can use for the rate or how the rate of the boat traveling with the current would be x plus y. Again, x is how fast the boat is traveling by itself. Y is the water current. So when we're traveling with the current, if we add these two together, that's overall how fast the boat would be traveling. Against the current, please be sure that you list x minus y and not y minus x. You know, ask yourself, what is slowing what down here? Is the boat slowing the river down, or is the river slowing the boat down? So in this case, the water current is taking away from the boat speed. We know that traveling with the current, we went 30 miles in 3 hours. With the current, 30 miles, 3 hours. And traveling against the current, 12 miles in 3 hours. So time, 3 hours, but we only traveled 12 miles. So now we can use our rate times time equals distance formula to come up with our two equations. So rate times time equals distance, so 3 times the quantity x plus y, 3 times the quantity x plus y is equal to 30, and also 3 times the quantity x minus y equals 12. So here is our system of equations that we need to solve by substitution or elimination. Now we can make things a little easier on us here. Notice that I can divide both sides of the equation by 3, both the top equation and the bottom equation. Both sides are divisible by 3. So dividing the top equation, both sides by 3, would give us x plus y is equal to 10, and dividing both sides of the bottom equation by 3 gives us x minus y equals 4. So now I look at these two equations, this system of equations, I see that my y terms are opposites of one another. So using the elimination method, we can go ahead and add both equations together right now. X plus x gives us 2x, plus y, negative y cancel out, and on the right hand side we have 10 plus 4 or 14. Divide both sides by 2 and we get x equals 7. Now we need to ask ourselves, does this value of x, is that the answer to the question that we're being asked? And I have to go up and look. They want to know, what is the rate of the boat in still water? We let x be the rate of the boat in still water. So yes, this value of x, 7, is the final answer. So the boat in still water is traveling at 7 miles per hour.